Hello everyone, this is Priyali Pundi from VIT University Chennai campus and I'm here to explain the concept of sliding window protocol. I will be explaining about its uses and types of it and how data is transmitted. So before knowing about the sliding window concept, we should know about two important parameters that are sequence number and sliding window. So what is a sequence number? It is a number given to each outbound frame. Here, first data is converted into frames and each frame is given a number. The range is generally from 0 to 2 to the power n minus 1, where n is an arbitrary number. Next is the sliding window. So these are the imaginary boxes or buffer storage areas in which a few number of frames lie at both transmitter and receiver. Suppose at the center side, there is a sliding window where you can transmit 3 frames one by one to the receiver and get the acknowledgement for each frame from the receiver. Now let's see a basic sliding window protocol example which will make the concept more clear. Suppose there is a sender and a receiver. It is not necessary that the size of sliding window at the sender's side and receiver's side are same. They may be same or different. For data transmission, suppose I want to send few frames which are numbered as 0, 1, 2, 3, 4 and so on. And those frames are to be received at the receiver's end. So here the sliding window size is 2, which means that the frames covered at the sender side by the sliding window will be 0 and 1. And same frames will be covered at the receiver's end. Now we see that according to the sliding window protocol, at any moment of time, any frame which is outside the sliding window is discarded. It means that at this particular position and time, the receiver will accept either 0 or 1 and frames 2, 3, 4 are discarded. So whenever an acknowledgement for each frame is received, the sliding window will move in the right direction. So now let's say frame 0 is sent to the receiver and the receiver given an acknowledgement to the sender. So as the sender gets the acknowledgement, the sliding window will shift right by 1 position at the sender's side. And as the other frame of data is received and the receiving sliding window will also shift right by 1. So now the sliding window position will be shifted at both sides. It means that the receiver can accept 1 and 2. So we can see that the receiving sliding window moves in the right direction when the data is received and acknowledgement is sent. And the sender sliding window moves in the right direction when the acknowledgement is received. So this is how a basic sliding window works. Now there are different types of ARQ methods like stop and wait, and then we have the go back in and selective repeat. The main difference between these types is the size of the window. Now if I say that the size of sender's window size and the size of receiver window size is 1, then it is known as stop and wait ARQ. So this is the reason that it is also called as 1-bit protocol, because it processes 1 bit at a time. Either you can send 1 bit or you can receive 1 bit. So here the maximum window size is 1. In this process, sender sends 1 frame and waits to get its acknowledgement. If positive acknowledgement is received, then the next frame is transmitted. And if the negative acknowledgement is received, the same frame will be retransmitted. So there are two conditions: positive acknowledgement and negative acknowledgement. Now how it works under normal conditions. So there is a sender and a receiver Here on both sides there are few data frames to be sent, and these frames are to be received at the receiver's end. If frames are numbered as 0, 1, 2, 3 here and at the receiver's end. So here the window size is 1 and the window size will cover 0 at both ends. Now here the frame 0 is sent, and once it is received by the receiver sends an acknowledgement, which means that the next frame is transmitted and the sliding window will be shifted in the right direction. And once the acknowledgement is received by the receiver, sliding window will also shift to the right direction by one position. Again, the frame 1 is sent and the acknowledgement is also received. So the sliding window is shifted to frame 2 on both sides. At a time, only one bit can be transmitted or one bit can be received. Now we will see for damaged frame. So there is a sender and receiver. So frame 0 is sent and received by the receiver, and it then sends the acknowledgement. Suppose frame 1 is sent, but it is either corrupted or damaged, which means that there is an error in frame 1. So now sender will receive the negative acknowledgement and retransmit the frame 1 again, and will receive the positive acknowledgement after that. Now we will see for lost data frame. Again, there is a sender and a receiver. Suppose the frame 0 is sent and the receiver sends the positive acknowledgement to the sender. In this situation, frame 1 is sent but it's lost in the process. That is, the receiver did not receive frame 1. Now it cannot send either positive acknowledgement or negative acknowledgement. So here there is a timeout mechanism used, stating that if either acknowledgement, which is positive, or negative acknowledgement is not received by the sender at a particular time, then the sender will retransmit again. So now there is another scenario for the lost acknowledgement. Suppose frame 0 is sent but the acknowledgement 0 is lost during the process. So there is a timeout mechanism which is used to make sure the sender retransmit the data again. In stop and wait ARQ, a sender sends a packet, then stops and then waits for acknowledgement for further processing of packets. Now, the biggest disadvantage of stop and wait ARQ is that the process is very inefficient, as you can process only one frame at a moment of time. So now we will see the go back N ARQ protocol. Here, several frames can be sent before receiving acknowledgement, which increases the efficiency. What is here important is the value of N is greater than 1, where N is the sender window size and the receiver window size is equal to 1. Now how does it work? In this method, if one frame is lost or damaged, all frames sent since the last frame acknowledgement are retransmitted. Suppose I have sent frames 1, 2, 3, 4. So for each frame, acknowledgement will be received, like acknowledgement of 1 and 2 are received, but the acknowledgement 3 is not received. So what happens is that after the last acknowledgement is received, the sender will retransmit frames 3 and 4. Now we will see a scenario of normal operation where the acknowledgement is lost. So here a sender is there and a receiver. Now the frames to be sent will be numbered as 0, 1, 2, 3, 4. In data link layer, the order in which frames are sent should be received in the same order, and then it is sent to be synchronous. So the receiver should get the frames in the same order, that is 0, 1, 2, 3 and 4. So here the frame 0 is sent and the sender will not wait for the acknowledgement. Instead, it will transmit the next frame immediately. So here frame 1, 2, 3 and 4 are sent to the receiver before waiting for the acknowledgement. Now here acknowledgement 0 and 1 are received, but acknowledgement 2 is lost during the process. So there is a timer attached to the sender. After waiting for a particular time, the sender side will see the last acknowledgement and will retransmit the frames 2, 3, 4 to the receiver. The frames 3 and 4 are discarded because they are being retransmitted. So this is a case when the acknowledgement is lost. Now let's see what happens when the data frame is lost or damaged. So here frame 0 and 1 are sent to the receiver and frame 2 gets lost in the process. And frame 3 is also sent. Acknowledgement 1 and 0 are received. So we can see frame 2 is lost and the receiver has received frame 0 and 1. The frame 2 was expected to be received, but instead of frame 2, frame 3 was received. Since it's not in the order, so the frame 3 will be discarded and a negative acknowledgement will be sent, that is NAK2, which means that the frame 2 is not received. Now the sender retransmits from frame 2, then frame 3 and so on. So this is the case when the data frame is lost. So if the frame 1 is damaged, it is also discarded and a negative acknowledgement NA1 is sent to the receiver, which means that the frame 1 was not received and was damaged. So here the important point is that stop and wait is a special case of go back N ARQ where the size of the sender is 1. So in go back N ARQ, the size of the sender window is greater than 1, but the size of receiver window is equal to 1. The problem using go back N process is that the receiver's side, only one frame can be processed at a time. If there is a frame lost or damaged, so the sender sees the last acknowledgement and retransmits the rest of the frames, which thereby decreases the efficiency. So the better way of doing it is the selective repeat ARQ. In this method, only the specific damaged or lost frame is retransmitted. So here the sender window size and the receiver window size should be greater than 1. And here if the frame is lost or damaged, only that frame will be retransmitted. So now we will see the normal operation. We will see how it will work. So there is a sender and a receiver, and we are sending frames from 0 to 4, and the receiver will receive the same. Now we will create a buffer storage area with frames 0, 1, 2, 3, 4 in the receiver's end, and once the frames are received, we will strike out these frames. So here 0 frame is sent, so 0 is striked out. Frame 1 is also sent, 1 is also striked out. Here the acknowledgement 0 and 1 are received by the sender. So now when we send frame 2, 2 is also striked out, but it gets lost during the process. In meantime, frame 3 and 4 are also sent. So the sender didn't get the acknowledgement 2. and so it will retransmit frame 2. In the receiver's side, at that point, the order will be frame 0, 1, 3, and 4. Now, if the frame 2 is received after frame 4, then the sorting technique can be applied to synchronize the frame. So this is how the selective repeat ARQ is processed. Thank you.